Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in this video we will learn about the types of components. So the component categories. Normally we are creating the components in the React, right? So whatever the component we are trying to create in the React, so whatever the component it is, it comes under certain categories. So we should divide the components into a certain category. So each category should have a particular responsibilities. So let's try to learn about the component categories in React. Not only in the React, we can also say in Angular and Vue.js like this also, these component categories will come into existence. So let's try to learn about this one. So which we will be using more often in the React.js. So let's go into the slideshow here. Fine. So most of the components in the React will naturally fall into one of these three categories. So normally we have three categories. We have more than three categories in the React, but most oftenly we will be using these categories is these three only. So most of the components, almost all the components in the React will naturally fall into these three categories. What are those three categories are? First one is the stateless or presentational component. So stateless or presentational, whatever it may be. So we can call it sometimes as stateless or sometimes we can call it as an presentational. So presentational components, and the another one is stateful components, and the last one is structural components. So these are the three categories, component categories, which comes into the React. We can categorize the components into any one of the category when we think about the components. So normally the components we can categorize into any one of this category. So any component, whatever the component you are trying to create in the React, it will come under any of these categories when we think about the components. So there are also other categories, but I think these make the most sense. So as I already told you, right, other than these three types of categories, so there are also other categories also, but these are the three most things which makes more sense. So let's start with the stateless or the presentational component. So starting with the stateless or presentational component, so as the name itself says that these don't have any state. So the state means nothing but whatever the thing you are trying to create with the use state and all those things we are doing it, right? So the variables which we are trying to create, the pieces of state or state variables, so those all the things will not be existing in the presentational components. So that is the reason. So that is the reason, as the name itself suggests, that it doesn't have any state in that one. Usually they are components that receive some props and then they simply present the data or even some other content, and therefore the name presentational. So normally, so what it will try to do, these presentational components is that doesn't have any use state. So state variables doesn't have inside that one. So normally they receive the data through the props. So through the component it will receive the data through the props, and using those props it will try to show the UI, or otherwise it will try to show the data, or otherwise so it will have only the UI content. So you will be having only HTML content or something like that, which you will be showing it. So therefore we call it as in presentational also. So if you are having any HTML content created in a component and you want to show that component, means that doesn't have any state or we are not receiving any props, means so those are presentational thing. And normally we can also say that it will receive some props data. So using the props data, it will try to present the data. So these are called as stateless or presentational components. Many times these are small components such as the logo, num results. Num results means something like if you are showing a tabular data, you will be showing that, right, number of results found. So those type of components or those type of data we call it as in presentational components. So normally those are called as a logo like this. Next category comes is the stateful components. So as you already the name itself understands, you are able to understand, these are simple components that do have state. So which you will be having the state, means then these are called as in stateful components. Now just because these components have state, that doesn't mean that they can't be highly reusable. So don't think that. So these presentational components are highly reusable. You can use it wherever you want. Why? Because it doesn't rely on the external data. So just you need to pass some props data if it takes it, or otherwise there is no need to pass the props data also for presentational product. Whereas the stateful components, so here you will be having the state. So that means it depends on the state. So it will be having its own memory location or memory variables, state variables. So now you don't think that if it is having the state means we cannot reuse those things. So we can reuse those stateful components also. Now finally the last one comes is the structural components. Structural components, what I can say is these are page layouts or screens of the application. So these are called as structural components, which are often times the result of composing many smaller components together. Sometimes we can also say that structural components which comprises of smaller components together. We can say it as a structural components. So these structural components can be huge and non-reusable components. So these structural components are non-reusable components. So these can be huge one. So that is the thing. Sometimes the structural components are sometimes quite small too. So these structural components are sometimes quite small too. What matters is that they are responsible for providing some sort of structure to application, such as pages or the layout. So that is the main thing which I want to explain you. So these structural components, sometimes it can be huge or sometimes it can be quite small too. The main agenda what I want to tell you is, the main fundamental what I want to tell you is, these structural components define the structure of the application, like such as pages or the layout. Therefore, these components might not be present in really small apps, but you will definitely have a few structural components as your app grows bigger and bigger. So generally, if you try to see, the smaller apps will be there, right? So these smaller apps and all those things, you will not see these structural components, but you will definitely need to have a structural components when your app is growing bigger and bigger. So this is all about the structural components, stateful components and the stateless component. Just revise one more time. So there are three component categories available in the React.js, that is stateless or presentational components, and another one is stateful components, and the last one is the structural components. So these are the components which you generally create. So any component you are creating in the React.js means those things comes under any one of this category. So stateless category or presentational component, what I can say is, so these are the components that does not have any state. So that means use state, we will not use the use state state variables. So how it will be having the data is, so we need to pass the data through the props. So when you send the data through the props, using that props data, it will show that it will present that data in a tabular form or anything. Or otherwise it will not, if you don't pass any props also, if you are having any static HTML content, you want to show it you want to reuse that one in your application, means you will create a component with that reusable HTML content, and you will try to use that component wherever you want it. So those is called as a presentational component. So stateless or presentational component. And the another one what I want to explain you is the stateful component. So stateful component means nothing but you can also pass the props to that one, but it will have its own state. So whenever you are trying to create with the use state variables like that, so it will have its own state. So that is the reason it is called as a stateful components. So normally the stateful components also we can reuse it just like the presentational components also. So there is nothing to think that we cannot reuse the stateful components. We can reuse it. And the last one comes under the structural components, which in the bigger apps we will be able to see more often. So these define the structure of the application, like pages, layout or anything like that. So these structural components are not reusable. So these are not reusable. So these can be huge or sometimes it can be small also. In smaller applications or smaller React apps, you will not able to see these structural components, whereas stateless and stateful components commonly you will be able to see it. So these are the in this video we will learn about the another new concept in the React.js, that is component composition. So what is this component composition? Don't think about the composition API which is present in the Vue.js. So this component composition is different thing. So let's try to explore about this one. In this video, we will learn about one essential principle concept, that is which we need to focus on, that is nothing but component composition. So it's a simple technique, so not a concept or anything, it's a simple technique. I will try to tell you. And the technique is called as a component composition. Before talking about component composition, let's see what happens when we simply use or include a component in another component in JSX. So normally this is the common thing which we will be use commonly in our scenarios, like we will create a component and we will use another component inside that component. So this is general scenario, right? So there is nothing new in this one. So before talking about the component composition, so let's see the traditional way, how we will be using the regular way, and what is the problem we will be finding and how we can solve that one using the component communication. Let's see here. So normally what I am trying to explain is we have created a component and we have included the another component inside that component. So that's a pretty simple. Let's say here, okay, so let's say that example, we have a model component. So this is our model component, function model, and inside that component we have included a success component, right? So this is a common thing. There is nothing new in this one. Okay, we have a model which displays a success message. Generally we can say that one is a success model, okay, which displays all the time a success message. And we want to reuse the model component and also the success component which simple renders a message, and I want to reuse that model component, and that model component just displays the success component which is simple renders a message. Here I have given the syntax for this success component also. Fine. So we are showing this success component. So here we are having a model component and here we are having a success component, and I want to reuse this model component. Let's try to reuse this one. And we just use the success component inside the model component, and that's what we are doing most of our time with the components. Just we are using inside the component. So this is the common concept, and just we use the success component inside the model component. So we are using the success component inside a model component, and we are doing most of the time with the like this only. So just we are using a component inside another component. However, when it comes to reusability, this creates a big problem. Okay, when now we are considering about making the model as a reusable, right? But it comes a big problem because the success component is really inside a model. They are deeply linked together. So that is the concept. We cannot reuse the model to show some other message other than the success message. It's true. So the model component has a success component deeply linked together. So whenever you are trying to use that model component, means the success component will be rendered. So they are deeply linked together. So we cannot reuse that model to show some other message other than the success message. For example, if you want to show an error message, we cannot show that one, right? In order to solve this one, we now bring the technique called as a component composition. So that is the technique. We can compose the model and success components together. So we can rewrite the model with a simple difference. So how we can rewrite this model component? Let's see. Here I have written function model and I am taking the children as a props. So we already learned about the children concept, and here I am showing the children. Fine. Now this component does not include a predefined component. So that is nothing but previously we have a predefined component, that is a success component, right? Now this model component doesn't have a predefined component. Instead it accepts children with a children prop. So just like we have learned before, if we get our success component again, okay, so here now the model, we are trying to call that model, right? And I am sending the component as a children. So here in between the opening and closing tag of the model, we are passing the success component. So that means we are sending that one as a children, and in the model the component will be caught with the children property, and in between this model we are showing the children property. So this is nothing but a component composition. In the first example, so which we are using the traditional way, so calling a success component inside the model, you know that success component is really ties to that model. We can call that model as a success model. Generally we can call that one as a success model because we cannot use it anywhere other than the success. So that is common thing. But with the component composition, we simply passed the success component right into the model and composed them together. Now we can pass in any other component which makes the model component highly reusable. So now not only the success model, we can also pass any other component whichever we want it. So essentially when we do component composition, we can fill the slot with any other component. So in between that one children, so there will be any type, we can pass any type of component so that the model will try to display that data. So that is the concept which I want to explain you. For example, let's say we need to display the model, but one that renders the error message. Well, that is pretty easy now. We just used the model component again, but this time we pass the error component as children. Fine, right? So that is pretty easy. Now we can pass, instead of success component, we can pass the error component inside the model thing, and that will be caught with the children prop, and the children prop will directly display that error component. So that is pretty easy right now. So component composition is the technique by combining different components by using the children prop or by explicitly defining components as a props. So this is the definition of this component composition. So component composition is the technique by combining different components by using the children prop. We can also send the components by using a children prop, or otherwise you can also define the component as a prop itself. So we can also send the component as a prop also. So that is one thing which I want to tell you. So these two ways you can send it. So now we can use component composition for two big reasons in two important situations. So now you may be getting doubt that where I can use this component composition. So that is the main thing, right? So well, I have understood about this component composition, but where I really need this component composition concept will be really used for in our application. So normally in two important situations, this component composition will be very much useful. So first one is when you want to create highly reusable and flexible components such as the model. So now I have shown you the model component, right, which is flexible right now. We can show any type of message in the model component by passing the component as a children prop. So like that, if you want to create a highly reusable and a flexible component such as a model, so in that situation we will be using this component composition. And the second situation is where we use the component composition is in order to fix a prop drilling. So here this is also another situation. So prop drilling means, so when you are having a component, so you want to send the prop to the deeper inside the components, means then we can use this prop drilling also. Okay, so for this in this prop drilling scenario also we will be using this component composition. So this is great for creating the layouts. So we'll try to see this one in a simple example after learning the concepts. So we will do a simple example for this one. So we will try to learn about this concept also in this one. So these two important situations where we are using. So in order to fix the prop drilling, so sending the props to the deeper inside the components in order to fix that issue, and also in order to make the highly reusable and flexible components, we will be using this component composition. So that's it about the component. In this video we will see how the component actually really works behind the React. Let's try to see in this video. So I am sharing a simple slideshow here. So in this video we will see the difference between React components, component instances, and also the React elements. So what is the difference between these three things? Let's try to learn about this one in this video. React components and the component instances and also the React elements. Knowing about the difference will make it a bit more clear what actually happens with your components as you use them. So this is one thing. So when you are trying to use the React components in your code, what actually happens? So if you try to know, then it will be very much we can able to understand it clearly. So let's look at the components first. So first we will look at the components. So three things are there, right? Components, component instances, and the React elements. First you will see about the components. Components are what we write in order to describe a piece of the user interface. So normally when we will be using the component we will be using it to describe or otherwise to write a piece of user interface, means UI code. So we'll create the component. Component is just a regular function, JavaScript function, but it is a function that returns the React elements. So it returns an element tree. Normally when you write a component function or anything, so it will consist of a regular JavaScript function only. But at the end of the function, what it will try to return is it returns the JSX elements. So that is nothing but a React elements. So it returns nothing but an element tree. And we usually write these elements using the JSX syntax. So this JSX syntax nothing but it will return the React elements. Now a component is a generic description of the UI. So we can essentially think of a component as a blueprint or a template. And out of this blueprint or template, React creates one or more multiple create component instances. So that means, so what I can say is, so here you can understand that the component which we are trying to create is nothing but a blueprint or a template of the HTML element, that is nothing but the React elements. And from this blueprint we will be creating one or multiple component instances. So here we will, from that function we will create a component instances. Let's try to see with an example. Now React does this each time where that we use component somewhere in our code. So whenever you are trying to use the component somewhere in your code, so it will try to execute that function. Let's say that for example we have a code like this. So here in our app function we have a code like this. So we are having a simple app function, that is nothing but app component. In this app component we are calling 3 times the tab component. So this tab component is also a regular JavaScript function, and that tab component we are calling it 3 times. So what will happen here in this one? The tab component what we saw in the last slide is included 3 times in the app component. So therefore 3 instances of the tab are placed in the component tree. So that means the 3 instances will be created in the component tree. That is nothing but the tab component. So here it will be the app and 3 times the tab instances it will be created. So in our application behind the scenes, this happens because React will call the tab function 3 times. So now you will be able to understand very clearly that, so whenever you are using the tab component means the function will get, the tab function will get executed. So now you have used 3 times the tab function, the tab component. So that means the React will call the tab function 3 times. We can say that an instance is like the actual physical manifestation of a component. So 3 instances will be created. So for this tab thing, while the component itself is really just a function what we wrote. So here the component instances means nothing but the physical manifestation. So that means the implementation of a component, and the component itself is nothing but just a function what we have written. So using that component we will create a component instances which will have all the manifestation of the component. Each instance holds its own state and props and also has its own life cycle. So whenever you are trying to create an instance from a regular component function, it will have its own state, own props and also its own life cycle also, which we'll try to learn it afterwards. So basically a component instance can be born, it will live for some time until it will eventually die. So that means the component instance, so the component will be there all the time, but the component instances will be created whenever you create a component, and it will be useful for the some time and automatically it will die after some time when you remove that component. Now we have used many times the term component and the component instance interchangeably. So we have used these both the terms, right? Component and also the component instance. We can say that we just say that component lifecycle and not the component instance lifecycle. So normally when you see outside or anything, so we will see about this component lifecycle, not the component instance lifecycle. And also we say that UI is made up of components, not of component instances. Even though component instances would technically be more accurate. So this is what I want to say. Sometimes we'll to say about the component lifecycle, component state like this. So normally, generally, technically, if you try to say, it's not a component lifecycle or component state. It is a component instance state and also a component instance lifecycle. You know that JSX will actually be converted, will actually get converted to multiple React.createElement function calls. So this one already we have learned in our first time. So how the JSX syntax alternatively we can write it using the React.createElement function. So normally behind the scenes the JSX syntax will be converted into this one only, React.createElement function calls. Then as a React calls this createElement function, the result will be a React element. So here whenever the React calls the React.createElement function, so the result, the output, the return value will be an React element. So a React element is basically the result of using a component in our code. So the React element is basically the result, the return value of using a component in our code. It's simply a big immutable JavaScript object. So what is this React element? It's a big immutable JavaScript object that React keeps in memory. So that is one thing. A React element basically contains all the information that is necessary in order to create a DOM elements for the current component instance. So what does this React element contains? It contains all the information that is necessary in order to create a DOM element. So in order to create the DOM elements, this React elements contains all the information. And so it's React element that will eventually be converted to actual DOM elements. So here the React element will convert into actual DOM elements and then the painted onto the screen by the browser. So that is the main thing. So here the React elements will eventually convert it into DOM elements, and this one will be painted onto the screen by the browser. So based on this one, based on all these, the DOM elements are the actual final and the visual representation of the component instance in the browser. So that is obviously we know about this one. So finally the DOM elements are the main actual final and visual representation of the component instance in the browser. It's not React elements that are rendered to the DOM. So don't think that React elements will render to the DOM. So the DOM elements, the React elements will be converted into the DOM elements, and the DOM elements will be responsible for visual representation of in the browser. So React elements will be there inside the React app and have nothing to do with the DOM. So they are simply converted to DOM elements when they are painted on the screen in this final step. So this is all about the component instance and also the React elements. So in this video we will learn about the React element and also the component instance in detail. So we have learned about in our previous video about the React elements, component and also the instances. So these are a little bit different terms in React which works closely together. So that one we have seen it. So now we will try to see and I will try to explain you step by step. So I will start with a simple example. So here you know that export default function and we'll be having an app, right? So this is our default app, and here let's say example, we are having it is returning a simple thing that is nothing but return p hello react. Okay, so this is a simple example which is trying to return, and if you see the example for this one, here you will be able to see hello react. Fine, right? So now here you need to understand that a React component in this one is literally the declaration of a component as we see in the previous here in this code snippet. So in this case we are using a functional component, so but it could be any other kind of React component like React class component also it can be. So now so we understood about this one. So the React so the component means the functional component, the JavaScript function which returns the React JSX element. Okay, so while more complex JSX is a mixture of HTML and also the JavaScript. So fine. Now we understood about this one. So now what I want to tell you is we can also extract a component from other component also. For example, let's say that we are having another component like greeting. Constant greeting is equal to, so this one is an component, so which I am trying to have it. So here I will do a text, I will try to send a text, and here I will return the paragraph element. I will use this text. So fine, I will use this greeting here in this one. So here I will be using this greeting, as a component greeting here also. So we can close it automatically. Yeah, and I want to send the text here. So here I will send the text as hello react. Same thing, the same output you will be able to see, but this time we are calling it using a component. Now if you try to see this component thing, if you see here the example, here the same output we are able to see. Okay, so now here, so we are rendering the component as a React element multiple times. So whenever a component gets rendered as an element, we create an instance of a component. So here whenever a component is getting rendered, so we are creating an instance of a component. So here you can call multiple times also. So that is what I want to explain you in our previous video. I have explained you. So here I can call this greeting multiple times. So here hello react 2. So here I can do it like this so that you will be able to see the 2 times. So here the React function is executed. It can be used multiple times as a React element in JSX. So when it is used, it becomes an instance of the component and lives in the React's components tree. So, so that is the main difference. That is the explanation of the React components element and also an instance in a nutshell. So now we will try to see in a deeper level. For example, let's say that here you are having a paragraph element, right? So here I will do the same thing like a paragraph element. I will take the hello react. I am using the same thing. And now here I will do the console.log, okay, of app. So I am calling as this one is a function. You know that this one is a function, right? So I can call it like this also as a function. So let's try to call this one as a function. Now when you try to call this one as a function, let's go to the inspect element, and if you try to see the console, okay, here is the console. Let's refresh this page. Yeah, now if you try to see here, so here you will be able to see an object, right? So whenever a React component gets called rendering this one, React calls its React.create element. So here it will create an object. So now if you try to focus on this object, so you are having something like $$ type of. So this returns, it is a type of symbol. Symbol is a JavaScript primitive data type, so which will be useful. So here this one is used in order to avoid the cross-site scripting. So why? Because through any API or anything, if an hacker or anyone wants to inject the component inside through the API means, so if it doesn't have this one, so why? Because symbol cannot be transferred through the API as a JSON, so it cannot be transferred. So it will try to check this one as a cross-site scripting. And here you will be able to see the props, and here you will be able to see a type, right? So here the type is nothing but a paragraph element, which is this one. Okay, so which is a paragraph element, is a type. and the content whatever it is having, it is passed as a children here. If you try to see here, it is passed as a children. Now the same thing we will try to call it as a component. So here I will try to do console.log app. I will try to call it like this. Now if you see the output for the same thing, okay, now if you try to see the output for the same thing, now first one here, if you try to see, the type is a function, so here it is creating it as an instance, whereas here when you are calling this one as a function, so normally it is calling here like this. Now this time it doesn't have any props, but here it is having a props of children hello react. So this is the difference between these two. Okay, so now what I want to tell you is, so here you can also use something like here, instead of using this one, you can also use create element, which comes under the React, and here I can write the paragraph element, and which is having a class name, so that is nothing but the class name, and that one is a danger or anything, you can use it, and here I can pass the hello React. So this one is one and the same only. Now if you try to see the output, then also I am able to see the output. So here when you try to do the console element, so here for this type you will be able to see a class name danger, and you are able to see in the props only the children as hello react, whereas here you will be able to see the props nothing is there. Why? Because we are not passing any props for this one, so here we need to pass the props here. So now, so that means you can also pass this one as a children, so this is also one and the same only, that's not a problem. So here also you can use the same thing, so it's also works one and the same. Now if you try to see the output for this one, then also you'll be able to see hello react this one. So the third argument is nothing but a children, so you can also pass it in the props also, that's not a problem. So now what happens when I try to call this one greeting, okay, when I try to call this greeting inside this one, so here inside this one, if I try to call a greeting, let's see what will happen. Now here I will try to use the greeting, okay, so this one when you try to call like this, so here we are able to see text is equal to hello world. I am using it like in hello world. Okay, if you try to see here, we are able to see the hello world. Fine, right? So we are able to see the hello world. Now the same thing what I will do is I will try to call it as a function. So here I will try to call it as a function. Let's see how it will happen. Now here I will use this greeting, okay, like this, and I will pass the text. Okay, I am calling it like this, greeting. Okay, so the same greeting I am calling it like this, or otherwise we will try to do it. What is happening here? Greeting signature request can only be used in, so like this it is trying to use it. So what I can do is, so here instead of this one, I will use a simple div, and I will try to write it inside this one. Okay, yeah, fine. So now if you try to see the output for this one, then so here then also we are able to see same thing, right? So whenever I am trying to call the function here, so then also I am able to see it. For example, let's say that I am using a count. Here I am using a state variable. Okay, hooks I am using count comma set count. So what will happen? Let's try to see. So count comma set count, or otherwise I will try to show you this one also. So here if you see in this one, in the components list, so for the app component, so here loading element reactor. Okay, let's try to inspect the element again. So let's go to the components here. Now here in this app you are not able to see this greeting component, whereas if you try to use this greeting, instead of calling like this, if you call it as a component here, now the instance will be created for this one, so then you will be able to see the output. So not output, in the component tree you will be able to see it. If you try to see here, see greeting is there. Why? Because the instance has been created for this one. Now for the same thing, if I try to call the same thing as like this greeting as a function, and here I will pass the text as hello Leela or anything. Okay, so if I am trying to use it like this, then also it will work. Hello Leela is come, but here it is not formed as an instance, whereas for the parent one, if you try to see, so here you will be able to see. So now what is happening here inside this one? So for example, let's say that here it is having a state, so hook it is having use state hook it is having. So what I can say is count comma set count. I am using something like this. So here is equal to use state of 0. So just I have used it like this. Now let's try to see whether we can able to see the output or not. So then also we are able to see the output without any problem. Now if you try to see the output for this one, for this greeting, so greeting has its own state, okay, but whereas this in this app, so this greeting is a part of this one, so the hook is a part of this one, so that means it doesn't have the second greeting doesn't have its own instance or its own state. So this is the problem. So this is the how you will be having. For example, let's say that you want to use it something like what I can say is, here you are having a button, let's say. So here I will do the same thing. So we will use the rewind fragment, and here let's say that I am having a button, okay, and here, and what I will do is plus I will try to update it. On click is equal to, so on click is equal to let's say that I will update this one, set count of count plus 1. Okay, whenever I click on this one, I will update this one. So here also I will show the count. Okay, so that's it. So it's a simple thing. Now let's see the output, we are able to see it or not. So if I try to click on this one, so it is getting updated, fine. Now if I try to click on this one, whether it will be getting updated, this one is also getting updated. So this one is also working fine. So now what will happen is, so now here I will use constant is visible. So you will be able to see this type of problem. Set is visible is equal to use state of false, okay, and here I will try to use this condition in such a way that if is visible is there, then only I want to show these two things. Those are nothing but like this, these two things I want to show it. Okay, so let's remove this one. Let's remove what I will try to do is I will use this what I can say, what is happening here, I will use this greeting. If is visible is there, ampersand, then only I want to use this greeting function. Now here I will use a button, okay, so here toggle, I will use a toggle, and here on click, on click I will use, what is happening here, yeah, on click is equal to, so I will write the code, set is visible of, so what I will try to do, not of is visible. So for the time being I will keep it like this. So now if you try to see the output for this one, so here if I try to click on the toggle, we are able to get a console error. So what it is happening, so here you should not use the rendered hooks during the previous render. So it is trying to tell you that, so here it has been called through in the condition. So what you need to remember is, so here the hooks and all those things, here the greeting whichever you are trying to call it here, so they are calling this one as in not an instance, as a method you are calling. So whenever you are trying to call the hooks as a condition, we cannot use the hooks as a condition. So here in such a way that how it is trying to behave is, so here it will be having a function in such a way that, and this one all it will try to return this one all. So like this, the code will be transferred into like this. So this is how you will be having. So this cannot be work. So this is what I want to explain you. Okay, so all the time whenever you are trying to use it, you need to use it like this only. So here it doesn't have its own life cycle. So whenever you are trying to call it using the greeting, it cannot have its own hooks or own life cycle. So that is the reason you are able to see this one. So now you will be able to see the output. Now if I click on the toggle, now you will be able to see the output. So this is the explanation which I want to tell you how the React elements component and component instances behave in the React.js. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So we are learning about the React.js building blocks, so how the React actually works behind the scenes. So we are learning about this concept. So we have learned about the component, how it is converted into a React element and component instances. What are the difference between those three? We have learned it. Now the second one which we need to learn is how the rendering actually works. So the React elements, after converting into the React elements normally what we have discussed it will render it to the browser. We have seen it. But the React elements, after generating the React elements has the data which should generate the DOM elements, and these DOM elements will be converted into a browser. So not converted into a browser, so it will paint it in the browser. So now this rendering phase, how the React elements convert into the DOM and all those things. So let's try to learn in this video. While we are building a React application, we are creating a bunch of components, right? So that's true. We also use these components inside other components as many times as we want, which will cause to create one or more component instances of each component. So now what I am trying to tell you is, so this is just a recap, something like that. So normally when we are trying to develop a React application, we will create huge number of components and we will use the component inside another component like that. So we have already discussed that when we create a component, the component instance will not be created. When we use this component, then only the component instance will be created. If you use this component multiple times, means that multiple component instances will be created. So that is what I am trying to explain it here. So whenever you are using components inside other component as many times as we want, so which will cause to create one or more component instances of each component. So here like this, it will be something like I created some basic thing. So component A will be there, which is created. And now whenever you are trying to use this component A, so like this component instance A1, A2, A3 like this. If you are using 3 times means, then 3 instances will be created. And the same scenario component B, if you are using 2 times means, so 2 instances will be created. These are actually physical components that live in our application. So that component instances are actually physical components that live in your application and holds the state and the props data. Now as React call each component instance, each JSX will produce a bunch of React.createElement function calls, which in turn will produce a React element for each component instance. So that is the thing. So whenever you are trying to use the component thing, whenever you're trying to use the component, so component instance will be created. So now as React calls each component instance, so the JSX will produce a bunch of create React elements function calls, which in turn will produce a create React element for each component instance. So for every component instance, a React element will be created. So this is the example. So here the 3 component instances are there. So for the component instance A1, a React element will be created. So like this, for every instances, a React element will be created. And ultimately the React elements will be converted to DOM elements and displayed as user interface on the screen. So that is the thing which I want to tell you. So overall, briefly, if I want to explain you is, so this is the concept. Now this is the thing. So component A and component B instances, this is like this is created and React element, and finally user interface is displayed on the screen. So now we have a pretty good understanding of the initial part of the process. So now transforming components to React elements. Now we need to know about the second part of the process. How these React elements converted to DOM and displayed on the screen. So here this is the thing. So how these React elements are converted to DOM and displayed on the screen. So this is the main thing which we need to know. Now we will see each of the phases involved in displaying our components onto the screen. In order to learn how React works internally behind the scenes, we need to know that each time when React starts a new render, each time React starts, a new render is triggered most of the time by updating state somewhere in the app. So now here you need to understand that. So we need to learn how the React actually works behind the scene. So now whenever a React starts, a render method will be triggered. So most of the time, so this render triggered will be triggered whenever we are updating the state somewhere in the app. So if you update the state somewhere in the app, a render method will be triggered. So what is this one? Whenever state changes, it triggers renders, and so it makes sense that the next phase is the render phase. So whenever any state changes, it triggers the renders. Now we will be able to understand that The next phase is the render phase. In this phase, the React calls our component functions and figures out how it should update the DOM. So in this render phase, what it will try to do, the React calls our component functions, so similar component functions, and figures out how it should update the DOM. However, it will not update the DOM directly. Now you need to understand that render is not updating the DOM or displaying elements in the screen. Rendering only happens internally inside React. It does not produce visual changes. So now here also you need to understand that the render will not update the DOM or display the elements in the screen. So just render only happens internally inside the React. It does not produce any visual effects, visual changes. In our previous videos, we have used the term rendering with the meaning of displaying elements on the screen because that was just easy to understand. So rendering actually means this render plus the next phase. So this is the meaning. So the actual definition is rendering means, so first it will try to render, then the next phase it will execute. So what is the next phase? We'll try to see it. And speaking of the next phase, once React knows how to update the DOM, it does so in commit phase. So this is the next phase. So render phase is completed, then it will go to the commit phase. So here in this commit phase, React knows how to update the DOM. In this commit phase, new elements might be placed in the DOM and already existing elements might get updated or deleted. So in this phase, in this commit phase, new elements in the DOM will be created or otherwise the existing elements will be updated or deleted. That means this commit phase is the actual phase of what we traditionally call rendering, not the render phase. Then finally browser noticed that the DOM has been updated and so it repaints the screen. So like this it will be. So first a render will be triggered. So trigger happens updating the state. So trigger, not a vehicle, not vehicle, that one, the spelling mistake. So trigger happens whenever we are updating the state somewhere. And render phase. So render is triggered. Then the render phase happens. React calls component functions and figures out how DOM should be updated. And in the commit phase, React actually writes to the DOM, updating, inserting and deleting elements, and the browser paints will happen. So these are the render phase means, so these are the four things it will be happen. Render is triggered, then render phase runs, and afterwards commit phase comes, and afterwards browser paint. There are actually two situations in which a render can be triggered. So one is initial render of the application, so initial bootstrap of the application, or whenever the state is updated on one or more component instances somewhere in the application, then the re-render happens. It's important to remember that the render process really is triggered for the entire application, not just for one single component. So this is also one of the important thing you need to understand, that whenever a render process is really started means it will be triggered for the entire application, not for just for single component. That doesn't mean that entire DOM is updated, but rendering is only about calling the component functions and figuring out what needs to change in the DOM later. So you cannot, so by calling this render and enter application means don't think that the DOM will be updated entirely, but here rendering is only about calling the component functions and all those things. In practice, it looks like React only re-renders the component where the state update happens, but that's not how it works. On the one thing I want to say that renders are not triggered immediately. So here React only re-renders the component where the state update happens, but that is not the thing which will works. And the renders are not triggered immediately. It is scheduled for when the JS engine has some free time. This is also called as batching of multiple state calls in event handlers. We'll try to discuss about this batching also. So this is all about the rendering phase. So now you have a pretty understanding about the rendering phase. So whenever any state occurs, the rendering will be triggered, then it will enter into the render phase. Render phase will call all the component functions and all those things and figures out how it should update the DOM. Then afterwards it will enter into another state, that is nothing but a commit phase. In this commit phase, it will try to do what I will say is, it will actually write the DOM, insert the DOM, update the DOM, whatever the thing it will want to update the elements, it will try to do it in the commit phase. And the last one, the browser will be painted. So this is the phases how the rendering actually works. So hope you understood about this rendering concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in this video, we will learn about the render phase. So these are some of the important concepts which we need to learn in the React. Why? Because So as I already told you, right, we are learning this React. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in this video we will learn about the render phase. So actually we have learned in our previous video about the how rendering actually works, right? So rendering is nothing but which will display into the screen. So creating the React element tree, and afterwards we will be displaying into the screen. So here in this phase, React element tree, it will have all the data that is related to how to create the DOM. So the concept, how it will be having the concept, how it will be rendering into the screen, how it will be painting into the screen, and how it will create the DOM elements and all those things. Let's try to see in this video. So learning about this concept and all those things doesn't have anything to work with the React.js. So if you don't know these concepts also, you can feel freely and you can work on the React.js also. But learning about this, what happens actually behind the scenes, is very much important. So if you are having a curious mind or anything, so which you want to learn these all things means, so it will help you a lot more. So let's try to learn about this render phase. So here let's see what we have learned about the mechanics of the state. So we in the previous video we have learned whenever a state is updated, so it will be re-rendered. A re-render will be triggered. So in the initial time, render will be triggered. Whenever, so when this state is updated, it will be rendered. Initial time it will be rendered, and the view will be updated according to that one. And here, so whenever in the view, so through the event listeners or anything, so if the state is updated, then update state will again re-render. So this will again update the view. So this is how the cycle will go on. So here in this render phase, we will be having so many steps will be involved. So that steps, all those things you will learn one by one. So here whenever the state updates, a render will be triggered, and in this render it will execute the component function, and component instances will be created, and React element tree will be created, and like that everything happens, and ultimately a DOM element tree DOM is constructed and it is painted on the screen. So this is how it will happen. So you need to understand that rendering will not update the screen or DOM. So this is one concept which we have discussed here. So the render thing which will happen, it will not update the DOM in the screen. And also React also does not completely discard the old view to re-render. So here whatever the view is there here, whenever a click event happened here, a state is updated, so it will go to the state, updated state has been filed, and it will render. And don't think that entire view will be discarded and again a new DOM will be reconstructed. Don't think like that. So these two are false. So how the React will handle these all the things, let's try to see. So now we will see how renders are actually performed in the render phase. At the beginning of the render phase, so when the rendering is happening, React will go through the entire component tree, take all the component instances that triggered a re-render and actually render them, which simply means calling the corresponding component functions. So whenever a render is happened, so React will go through the entire component tree and it will take the entire component instances and all those things. So it will just simply call the component functions. So this will create the updated React elements. So when these component instances and all those things are created, so you know that, right? So React elements has been created, which altogether make up the so-called virtual DOM. So this React element tree is nothing but it is called as a virtual DOM only. And this word we have heard it so many times before, and let's learn about this, what this actually virtual DOM is. So in the initial render, so when the initial render is happening, React will take the entire component tree and transform it into a one big React element tree, which is basically called as an React element tree like this. So here this is our component tree which we will be having. So you are having at the top app, and you will be having navbar, body, and a footer. So let's think it as a profile or anything, and in this body you are having a model and a tweet. Okay, component tree. And here this React element tree. So when these component instances and all those things are executed, so proportionately React element tree will be created. An app, navbar, body, footer, model, tweet like this. Virtual DOM is just a tree of all the React elements created from all the instances in the component tree. So this is the definition. Virtual DOM is just a tree of all the React elements created from the instances of in the component tree. And it's relatively cheap and fast to create a tree like this, even if we need many iterations of it, because in the end it's just a JavaScript object. Now virtual DOM is probably the most hyped and most used term when people describe about what React is and how it works. But if we think about it, if the virtual DOM is just a simple object, it's actually not such a big deal, right? So it's a virtual DOM is just a big simple object. Official documentation does not mention the term virtual DOM anywhere right now. So in our new official documentation in the React, so the term virtual DOM is not being used anywhere, but everyone uses it because it sounds nice that the term React Elementary than the React Elementary. So if I try to say React Elementary means, then that virtual DOM word sounds better. So that is the reason. So now here you need to understand that React Elementary and the virtual DOM is both are one and the same only. And also some people confused about the term Shadow DOM also, even though it has nothing to do with the virtual DOM in React. So the Shadow DOM is just a browser technology. So if you want to know more about the Shadow DOM and all those things, so I have done the videos on this Shadow DOM in the Angular animations courses. So there I have covered more about the Shadow DOM concept and all those things. If you have doubts, if you want to know more about this one, you can refer to those videos. Let's say there is a state update in the profile component. So let's say here I have used a profile component. So here the state has been updated, in which it will trigger the re-render. So what will trigger the re-render? So profile, it will trigger the re-render. This means that React will call the function of the component profile. So the profile component function will be called and place the new React element, so in a new virtual DOM. So that is the main thing. Now the important part is that, so here the important part you need to understand is that whenever React renders a component, so whenever a React renders a component, that render will cause all of its child components to be rendered as well. No matter if the props also changed that we pass it down have changed or not. So whenever the props are changed or state are changed, anything, if a component is re-rendered means, then all the child components which are having for that component will also be re-rendered. So if the updated component returns the component, those nested components will be re-rendered as well all the way down the component tree. So this is the important thing you need to understand. This means that if you update the highest component, all the components will be re-rendered all the way down the component tree. But this doesn't mean that the entire DOM is updated. It's just a virtual DOM that will be recreated. So here this is the important thing which you need to understand, that so whenever a component is updated, all the child components below that one will be re-rendered again. That means it will be re-executed and these all the instances or the objects will be updated in the new virtual DOM, in the virtual DOM. Now that means that, so if the virtual DOM is updated, that don't think that the entire DOM is got updated. So the main physical DOM is got updated. Don't think like that. Only the virtual DOM has been created. So this new virtual DOM was created after the state update will get reconciled with the current so-called fiber tree. So this is the important concept which we will try to learn about this one. So when the virtual DOM is created after the state update, okay, after the state update only the virtual DOM is created. So before this virtual DOM creation and all those things will get reconciled with the current so-called fiber tree. So that means reconciled means it's a checking something like that. I will discuss about the reconciliation process also. So it will be reconciled with the fiber tree. So we will be having another tree that is nothing but a fiber tree. So it will be reconciled with the fiber tree with the new virtual DOM as it exists before the state update. So this fiber tree exists before the state update only. This reconciliation is done in React reconciler which is called fiber. Okay, we will learn about this fiber also. That's why we have a fiber tree. Then the results of this reconciliation process is gonna be an updated fiber tree. So when the reconciliation process and all the things is completed, we will get an updated fiber tree. So a tree that will eventually be used to write to the DOM. So this tree will be written to the DOM. So let's learn what reconciliation is and why do we need this one in it next video. So now you will be having a little bit doubts and all those things. What is this reconciliation? What is this happening? Up to virtual DOM you are able to understand clearly, right? So before when a state is updated and all those things, so here the components and all the child components, everything got re-rendered. Okay, a new virtual DOM object will be created. Now this entire virtual DOM cannot go to the DOM and it will cannot update the paint on the screen. So here another object, another tree will be having that is called as a fiber, and this fiber and this virtual DOM will be compiled using a reconciliation process. So we'll try to see about this reconciliation process, and it will generate a new one that is nothing but an updated fiber tree. So this fiber tree will be there, and this fiber tree will be ultimately written to the DOM. And again, when a new another state updated, so again a new virtual DOM will be created. This updated fiber tree and this one will be rechecked, and again it will create a new updated fiber tree. So like this the process will be going on. So hope you understood about this render phase, about the virtual DOM and all those things. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about the reconciliation fiber tree. In the previous video, we have learned about the render phase. So how the render phase is happening and all those things we have seen it. Now we have stopped it at the place of reconciliation after creating the virtual DOM. So what will happen? So let's try to learn about this fiber tree and all those things. In this video, we will learn about the reconciliation and the fiber tree. So try to learn it, try to understand it very carefully. So it is little bit of confused things to most of the developers. So I will try to explain you as simple as possible. So let's learn it. The reconciliation process result is gonna be an updated fiber tree. So the process which the reconciler will do is the result will be an updated fiber tree. What is this updated fiber tree and all those things? We'll try to learn it. This tree will eventually be used to write to the DOM. So this is the tree which will eventually use it to write to the DOM, not the virtual DOM. So virtual DOM doesn't have anything to do with the DOM updates. So that DOM updates, everything will be done through the fiber tree. So that is also an updated fiber tree. So this is the high level overview of the input and output of the reconciliation. So now what is the process? We'll try to. Now we need to understand that what reconciliation is and how it works. So this is the main question what we will be having. Now you may be wondering that why we need to have a virtual DOM, a reconciler and the fiber trees. So these three technical terms we have learned it, right? Virtual DOM we understood. For reconciliation, virtual DOM is nothing but the React element tree only. So whatever the component got executed, it returns the component function, returns the React element. So that is that all the component structure and all the things combines the React element tree. Now a reconciliation and those fiber trees. So reconciler means nothing but it will create an fiber tree. So using that virtual DOM and these fiber trees. So what is this fiber trees? Why not simply update the entire DOM whenever the state changes somewhere in the app? So normally using the jQuery and all those things. So what the jQuery, JavaScript and all those things will do is it will simply directly update the DOM whenever the state changes or data changes. Remember how we said that creating the virtual DOM so that the React element tree, so virtual DOM is nothing but the React element tree for the entire app is cheap. So that means for creating, updating the entire the virtual DOM and all those things is cheap and fast because it is just a JavaScript object. So because of the virtual DOM and all those things is JavaScript object, creating of this virtual DOM is very easy and also cheap. Writing to the DOM is not so cheap and fast. So writing the data directly to the DOM is not so cheap and fast. It would extremely inefficient and wasteful to always write the entire virtual DOM to the actual DOM each time that a render was triggered. So this is, so whenever you are trying to write the entire DOM using the virtual DOM means it is extremely inefficient and wasteful. Whenever a render is triggered, so instead of updating the virtual DOM, you go and directly do the actual DOM update means, so this will be very inefficient. So when the state changes somewhere in the app, only a small portion of the DOM needs to be updated and the rest that is already present can be reused. So this is the one step. So you already know about this one. I am moving on to the forward. Now of course on the initial render, there is no way around to create the entire DOM from scratch. So but from there on, doing so does not make sense anything. So initial render, we will update everything in the DOM. So after initial render, whenever a render is triggered, whenever a state is updated in the app, so doing entire DOM update from the scratch is doesn't make any sense. Why? Because most of the DOM will be reused. Only some part of the DOM data only will be changing, modified. So whenever a render is triggered, React will try to be as efficient as possible by reusing as much of the existed DOM tree as possible. How does React actually do this one? So this is the phase. So here this is the place where you need to understand. So whenever a render is triggered, React tries to be as efficient as possible by reusing as much of the DOM tree. So how does this do? Using the reconciliation thing, we'll try to learn it. So that's where a process called reconciliation comes into play. So this is the place where reconciliation comes into play. This is basically deciding exactly which DOM elements need to be inserted, deleted or updated in order to reflect the latest state changes. So this reconciliation is basically, it is the place where it will decide the DOM elements where it need to be inserted, deleted or updated in order to reflect the latest state changes. So a process of reconciliation is gonna be a list of DOM operations that are necessary to update the current DOM with a new state. Now reconciliation is processed by a reconciler. So this process is done by a reconciler. So this process entire thing, so which will do is it's a nothing but a reconciler. And we can say that the reconciler really is the engine of the React. It's like a heart of the React. So this is the reconciler that makes us to never touch the DOM directly and instead simply tell React what the next snapshot of the UI should look like based on the state. So this is the place where the reconciler will do all the things and it will try to take the snapshot of the UI. So how the UI should look like based on the state. As I mentioned before, the current reconciler is called Fiber. Okay. And this is how it works. So here the reconciler is called as a Fiber. So Fiber means nothing but the React element only. This is the updated version, but I will try to explain you. During the initial render of the application, Fiber takes the entire React element tree. So first when the initial render is happening, so all the components get executed and the result then the return and the result of that one will be a component instances, right? So React element, and this all components everything got executed, it will form a React element tree. In the initial render we don't have Fiber and everything, so we don't have the thing, and React element tree will be converted into a Fiber tree also. So that means we will be having two types of trees. One is a React element tree and also another one is a Fiber tree. So entire React elements, so the virtual DOM based on it builds yet another tree which is called as a Fiber tree. So here React element tree is called as a virtual DOM and based on it builds in another tree that is nothing but a Fiber tree. So here we are having React element tree and also a Fiber tree. React element tree, when I am trying to tell, think that that one is also a virtual DOM. So it will look like this. So initial render, first the virtual DOM React element tree will be created. Here you will be able to see app, you are having navbar model button and overlay H3 button. So here you will be able to see both the HTML elements and also the component elements, everything we are having. And the same thing the Fiber tree will be created here also. Okay, so here the same thing Fiber tree will be created. So try to understand that the what I can say is the placement of these all the fibers and React elements, the thing is little bit different. We'll try to explain it. The Fiber tree is a special internal tree where for each component instance and the DOM element in the app. So here each component instance and also a DOM element like H3 button is also placed. This is one called as a Fiber. So there is one, so each one is called as a Fiber. So total comprise of a Fiber tree. So what is the special about this tree is that unlike React element in the virtual DOM, fibers are not recreated on every render. So these fibers are not created on every re-render. So the Fiber tree is never destroyed. So Fiber tree will never be destroyed. Once it is created over the initial render, it will be mutated over and over again in the future reconciliation steps. So it will be mutated over and over in the future reconciliation steps. So here the Fiber tree will never be deleted. So it will be mutated over and over. And this makes Fibers the perfect place for keeping track of the things like current component, state, props, side effects, list of used hooks and more. So the actual state and props of any component instances that we see on the screen are internally stored inside the corresponding Fiber in the Fiber tree. So each component instances like states, props and all those things will be stored in each Fiber also. Each Fiber also contains the queue of work called like updating state, updating refs, running side effects, performing DOM updates and so on. So each Fiber also has these all the things. This is why a Fiber is also defined as a unit of work. So it is also called as an unit of work also, Fiber. Now if you see that the Fibers are arranged in a different way than the elements in the React element tree. So React element tree has something like a parent-child relationship, whereas the React doesn't have Fibers doesn't have a parent-child relationship. Instead of having a parent-child relationship, each first child has a link to its parent, and all other children then have a link to this previous sibling. So like this it will be having. So here if you try to see, so app will be with navbar, model and button, whereas app will be with navbar will go to the model and model to the button. So that means each like a linked list it will be, and model to the overlay will be connected to the H3 will be connected to the button. So it will be connected to the siblings, not the parent child relationship it will be. So like this it will be. Now where we are, yeah. So it's like a linked list. So this type of structure is called as a linked list and makes it easier for React to process the work that is associated with each fiber. Now we also see that both trees include not only React elements or components but also regular DOM elements such as H3 and button elements in the example. So we are able to see the H3 and buttons also in the DOM elements, not only the component instances. So both trees really are a complete representation of the entire DOM structure, not just of React components. So here you need to understand that virtual DOM and also the fiber tree. So both are the complete representation of the entire DOM structure, not just React components. Now going back to the idea of that fibers are units of work, and an extremely important characteristics of the fiber reconciler is that work can be performed asynchronously. So this is one thing you need to understand, that the work is performed asynchronously. Rendering process can be split into chunks, tasks can be prioritized, and work can be paused, reused or thrown away if not valid anymore. So these all are done asynchronously only. This all happens automatically behind the scenes. It's completely invisible to the developers. There are however also some practical uses of this asynchronous rendering also. It enables modern so-called concurrent features like suspense or transitions which are starting in the React 18. So because of this one, so these are all concurrent features also we can use it. It also allows the rendering process to pause and resume later so that it won't block the browser's JavaScript engine with too long renders, which can be problematic for performance in large applications. Again, this is only possible because the render phase does not produce any visible output to the DOM. So this is only possible because the render phase doesn't produce visible output to the DOM. Now we understood what the fiber reconciler is and how the fiber tree works. But now it's time to talk about what fiber actually does, which is the reconciliation process. So the best way to explain how reconciliation works with a practical example. I will try to explain you with a practical example. So here let's say that the first time in the app you have a state that is nothing but show model is equal to true, and we are having a virtual DOM that is nothing but a React elementary, and app is directly with the model, overlay and H3. So when the show model becomes false means the entire model, overlay, H3 button. So these all the things should be changed, and also the button component also should be, the text content should be updated. So here using this initial render, a fiber tree will be created here. So after creation of the fiber tree, when the state shows show model is false, then this will then trigger a re-render which will create a new virtual DOM. So here the new virtual DOM is created. Why? Because show model is equal to false, right? So the model, overlay, H3 buttons, everything will be removed, and only navbar and button only will be available in the virtual DOM. Now the fiber tree will be like that only. So this is the fiber tree, it will be like this only. So now if you try to see, this is the virtual DOM, and here this is the fiber tree. When this is the fiber tree means app and navbar doesn't have anything to affect when this state has been changed. But this model, overlay which are in red color has been removed, and this button based on the state value, so it is updating some data inside this one. So that means here the DOM elements, these are the only things which are getting updated, fiber tree, fiber elements, and these two are fibers are not getting updated. So now this new virtual DOM will be reconciled with the current fiber tree, which will result in this updated tree, which is called an work in progress tree. So this is the updated fiber tree. Again, this is only possible because the render phase does not produce any visible output to the DOM yet. So render phase doesn't produce any visible DOM. Now we understood what the fiber reconciler is and how the fiber tree works, but now it's time to talk about what fiber actually does, which is the reconciliation thing. So now, so here, so this is the thing. After the fiber tree update, the changes of the list is called as a list of effects. So here when you try to see here this fiber tree, so when the changes are all the things are completed, the effects are completed, so this is called as a list of effects. Okay. So this list of effects is nothing but updated tree only. The result of this render phase contains all the list of DOM updates, and it is sent to the next phase, that is commit phase. So this is also next phase. So here up to now the visible DOM painting, the browser paint has not been happened. So now the creation of this updated DOM has been created. Now it is sent into the commit phase. So that fiber tree. Now this what will happen in the commit phase, which we will discuss in the next video. So this is all about the reconciliation phase, fiber tree and the virtual DOM. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. So in the previous video we have seen about the reconciliation process. So when the list of DOM updates has been rendered in the render phase completed, so we know that it will not produce the visual output. So then it will be passed to the next phase. So that is nothing but the commit phase. So what is this commit phase and how this commit phase will paint the browser or it will show the visual output to the screen? Let's try to see in this video. In the previous video we have seen about the render phase which results in the list of DOM updates. So we have seen it. This list will now get used in the commit phase. So the list which we are trying to get the DOM updates will now be used in the commit phase. So this is the next phase and the final phase. The work in progress fiber tree also goes into the commit phase. So there the fiber tree will be updated, right? So it will be checking with the reconciler with the virtual DOM and the current fiber tree. It will try to check the changes, whether any changes in the elements has been applied or not using the diffing algorithm. We will discuss about this diffing algorithm also in the reconciler. So you will get a work in progress fiber tree. So this will be also goes into the commit phase. So the list of all the DOM updates and also the work in progress fiber tree. You know that the commit phase is where React finally writes to the DOM. So this is the commit phase where React finally writes to the DOM. It inserts, deletes and updates the DOM elements. You will also sometimes read that React flushes updates the DOM in this phase. So basically React goes through the effects list that was created during the rendering and applies them one by one to the actual DOM elements that were in the already existing DOM tree. So we know that the effects list, so the list of the fiber tree or the list of the DOM list effects will come from the rendering phase, right? So that rendering phase will go to the commit phase, and in this commit phase what it will try to do is it will check one by one with the actual DOM elements that are already existing in the DOM tree. We say that the commit phase is synchronous. So the render phase is an asynchronous thing. So it can pause, resume, and it can divide into chunks. The chunks by chunks it will be divided. It will be executed. Whereas the commit phase is not asynchronous. It isn't synchronous. Unlike the rendering phase, which can be paused. So committing cannot be interrupted. So when you are trying to do the commit phase, so that means write to the DOM. So that should not be interrupted. So that is the reason it is a synchronous. Now this is necessary so that the DOM never show partial results, which ensures that the UI always stays consistent. So when this commit phase is asynchronous means, for example, so this DOM will show some partial results and it will go some back to where that one, right? So it should not happen like that. So to ensure that the UI always stays consistent. In fact, that the whole point of dividing the entire process into the render phase and the commit phase is the first phase. So that is the reason only the entire process is divided into two phases. That is, one is the render phase and the commit phase. So the render phase is an asynchronous and the commit phase is an synchronous. So the render phase will not produce any visual output. So that is the reason it will happen asynchronously without blocking the JavaScript main thread. Whereas the commit phase, it will write to the DOM, UI changes will be happening in the browser pane, right? So that should be synchronous. It should not be interrupted. It's so that rendering can be paused, resumed and discarded, and the results of all that rendering can then be flushed to the DOM in one go. So in one go, it will be all the things will be done in the commit phase. Then once the commit phase is completed, the work in progress fiber tree becomes the current fiber tree for the next render cycle. So this one is as usual. So the work in progress fiber tree, which is the updated fiber tree, is there, right? When the commit phase everything is completed, this fiber tree will become the current fiber tree, and the new virtual DOM, when it is created, it will check with this current fiber tree. That's because, remember, fiber trees are never discarded or never recreated from the scratch. Instead, they are reused. In order to save precious rendering time, and with that we close up the commit phase. The browser will then notice that the DOM has been changed, and as a result it will repaint the screen. So that is the main thing. Whenever it has some idle time, so this is where the DOM updated are finally made visible to the user in the form of an updated user interface. Now I am not gonna go into how this phase works. So this DOM updates and all those things I am not going. So this is the how it will be happening, because this is really more about how browsers work internally and not React. So that painting and all those things, the browser works internally. However, there is still one more thing that we need to talk about. So the browser paint phase that we just mentioned is of course performed by whatever the browser the user is using. So this browser paint and all those things happens. So it opens whatever the browser they are using, so that they have their own mechanism. But I want to discuss another thing, important thing. And the render phase is obviously performed by the React library. So you know that the render phase, so which we are having that render phase, right? So creating a React element tree and reconciliation and to creating an updated fiber tree. So these all the things render phase will be done by a React library only. But what about the commit phase? So then what could be this commit phase? This commit phase is not done by the React library. We would think that it is also done by React, right? But actually that is not true. It's actually done by a separate library that writes to the DOM, and it is called as a React DOM. So this is where we will be using this React DOM. So this React DOM will try to do these all the things. That is nothing but the commit phase. So not very creative, but that's what it's called. So in fact, React itself does never touch the DOM. So React library never touches the DOM, and it actually has no idea where the result of this render phase will actually be committed and painted. So the React library will not have any idea where the result, the output of this render phase will actually be going and painted. So React only does the render phase but not the commit phase. And the reason for that is that React itself was designed to be used independently from the platform. So React library is developed to be used independently from the platform, where elements will actually be shown, and the React can be used in many different hosts. I will try to tell you about this host. Now up until this point, we have only ever thought of React in conjunction with the DOM, because we usually use it to build web applications, and 90% of the cases that actually what we do with the React. So 90% of the web applications and all those things, when we are trying to use the React, we use it for the web application. Web application means the browser thing. Browser thing means, so it comes with the combination with the DOM. React can be used with other hosts as well. For example, we can develop native mobile apps for iOS and Android using React Native, or we can build videos using React using a package called Remotion. So these are also other things. And also we can develop all types of documents like Word or PDF documents, Figma designs, and all those things using a different packages, so called rendered. So these are all the things. This React library is not the one responsible for writing to the DOM. So that is the reason. So React library is not responsible for writing into the DOM, because the DOM is just one of many hosts to which React apps can be committed. So to which they can be output basically. And for each of these hosts, we have a different package that we can use, and that's why in our index.js file we always import both React and React DOM, right? So that is the reason. And so now you know the exact reason why we have to do that already. All right. So after looking at all these phrases in so much details, let's have a quick recap. So that is the thing actually happens in the commit phase. So this is all the concept what we have learned. Now I will try to do a quick recap what exactly these all the things will do. The whole process of rendering and displaying a React application on the screen starts with a trigger. So this is the one thing you already know. So from the 3-4 videos onwards, we are discussing this one only. So when it will start with a trigger. So this can be applied at the initial render or in any component, whether any component state will be updated. So which can be at the initial render of the application or a state update in one of the component instances. This then triggers the render phase, which does not produce any visual output. So this is the main thing you need to understand. Render phase does not produce any visual output. So this phase starts by rendering all component instances that need a re-render. And rendering in React simply means to call the component functions. This will create one or more updated React elements which will be placed in a new virtual DOM, which is simply a tree of React elements. So this is all the concept you know. Now what's really important to remember about this process is that rendering a component will cause all of its child components to be rendered, as well as no matter if props are changed or not. So if a component is rendered means all the child components which are having in that component will be re-rendered, no matter if the props is changed also. This is because React doesn't know whether children have been affected by the parent re-rendering or not. So that is the reason. Next, this new virtual DOM needs to be reconciled with the current fiber tree. So with the representation of the elementary before the state update, this is necessary because it would be slow and inefficient to destroy and rebuild the entire DOM tree each time that something on the screen must be updated. So we need to compare with the current fiber tree. So why? Because we are doing is, so if, converting this entire new virtual DOM into a current fiber tree, it will take inefficient thing and it will take so much time. Instead, reconciliation tries to reuse as much of the DOM as possible. Why? Because reconciliation will try to use as much of as the DOM as possible by finding the smallest number of DOM updates that reflect the latest state update on the screen. Now this reconciliation process is done using a reconciler called fiber, which works with the immutable data structure called fiber tree. It's a mutable data actually. And this tree for each React element and the DOM element, there is a fiber, and this fiber holds the actual component state, props, and the queue of work. After reconciliation, this queue of work will contain the DOM updated that are needed for that element. Now the computation of these DOM updates is performed by a diffing algorithm, which step by step compares the elements in the new virtual DOM with the elements in the current fiber tree to see what has changed. So the final result of the rendering phase, so basically the reconciliation and diffing process is the second updated fiber tree, as well as a list of all necessary DOM updates. Now it's important to note that the rendering phase is asynchronous, so fiber can split work into chunks, pause and resume some work later. So this is one thing you need to understand. The final result of the rendering phase is the list of DOM updates will finally actually be written to the DOM in the commit phase. This phase, a so-called render phase like React DOM, will insert, delete and update DOM elements so that we end up with an updated DOM that reflects the new state of the application. So this is the overall total quick recap what it will happen. The commit phase, what I have discussed, is an actually synchronous. So all the DOM updated are performed in one go in order to ensure a consistent UI over time. Now once the browser realizes that the DOM has been updated, it starts a new browser pane to visually update the user interface on the screen. So now I hope that you have understood such a long process. Keep in mind that you can build React apps without being aware that most of these things even exist. So this is one thing. But knowing these all the concepts behind the scene is very much important. So without knowing these things also, you can develop the React apps. So what is happening behind the scenes also, there is nothing necessary to understand it. So that's it guys about the render phase and also the commit phase. There is one thing left over, that is nothing but the diffing algorithm. How the diffing algorithm works, I will try to explain you in the next video with a practical example also. Hope you understood about this commit phase. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Guys, Hey guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about the final concept, that is about the diffing algorithm. So this one comes in the reconciliation thing in the render phase. So when we are trying to create a new updated fiber tree, so this diffing algorithm will be used. Let's try to learn about this one. In this video, we will see one of the important thing in render phase, which was the diffing algorithm. That is a part of the reconciliation process. We didn't really go deep into how the diffing works, and since that is also a really important one, so we'll try to do it that one. Diffing is first of all based on the two fundamental assumptions. So this diffing algorithm, how it will work is, so it will have a two fundamental assumptions. First one is the two elements of different types will produce different trees. So we'll try to explore this one with an example also. First one is the two elements of different types will produce a different tree. Second one is that the elements with a stable key, so a key that is consistent over time, will stay same across the renders. So let's try to take the first one. Remember that diffing is comparing elements step by step between two renders based on their position in the tree. And there are basically two different situations that need to be considered. So what is that one? First, having two different elements at the same position. So if you are having the two different elements at the same position in the tree between the two renders, and a second one having the same element at the same position in the tree, so those are the only two situations in the matter. So I'll try to show you these two situations. Now let's start with the first situation, that different elements are at the same position. Let's say that at the same point or at the same position an application is re-rendered, and in the diffing process we find that an element has changed in a certain position of a tree. Let's say that's example here. So here at the top different DOM element is there. Here at the top we are having a div element, and in this div element we are having a search bar component, and down we are having some JSX elements. Fine. So here the div element has been changed to header element. So we have changed the different DOM element. So this has been changed to header, and search bar header, everything is same, but only the div has changed to header. Now let's see what will happen in this situation, how the diffing algorithm works. Let's see. So now we are looking at the JSX code which leads to the tree, because I find it very little bit easier. Here the DOM element changing like this. Changing simply means that the type of the element has changed from div to a header. So here it has been changed from div to a header. Div to a header. In this situation, React will assume that the element itself plus all its children are no longer valid. So in this situation, so here in this situation, the element, whichever the element you are having, this one, right, header element, not only the header element, and also what are all the elements present in the child. So it will, the algorithm will think that these are not at all valid, these are no longer valid. Therefore all these elements will actually be destroyed and removed from the DOM, and also including their state also. So every element will be deleted. So the child elements and also the components, everything including the state also will get destroyed and removed from the DOM. In this example, both the div element and the search bar component will be removed from the DOM and will then be rebuilt as a header with a brand new search bar component instance as the child. So I think hopefully you are able to understand this point. So if the child elements stays the same across renders, the tree will actually get rebuilt, but it gets rebuilt with a brand new elements. And so if there are any components with the state will not be recovered. This effectively resets state, and this has a huge implications for the way that React applications work in practice. So here you will be able to see now in the second situation is we are having a different React element. So here we are having a div. So here it should be div only. So my mistake here. So let's assume that let's try to change it here. So let's say that here we are having a div element, not the header element. Okay, div element. Now here in this slideshow, what I want to tell you is, so in this one only the component has been changed. So from search bar component to profile menu component has been changed. In the second example here, the search bar component has changed to profile menu component, and therefore the search bar is again completely destroyed, including its state, and removed from the DOM also. So this phase is also pretty much clear. Now the second situation we need to know. The second situation is when between two renders we have the exact same element at the same position in the tree, and this one actually is more straightforward. So what will be this one? Example C. So here we are having the same div element and search bar, and here also let's try to, so it is also my mistake only. So these are small mistakes which I have did it, and here also we are having a search bar only. Okay, so now let's try to make it as a div. Yeah, now here in this slideshow, if you observe carefully, so now the class name hidden has been changed to class name active. The elements are at the same position and the elements are also same, and the search bar and search bar, the elements, everything is same, but here the changed is only the attribute thing. So in this situation what it will try to do. So here is the second thing. So here we are having search bar weight is equal to 1, and here search bar weight is equal to 5. So here only the props has been changed, but the elements and everything is one and the same only. So same React element with different attributes. In this example, the elements will be simply kept in the DOM, and that includes all child elements, and more importantly the component state. So here the component state, the child elements and everything will be kept in the DOM like that only. So why? Because the element itself has not been changed, only the attributes has been changed. Now this may sound pretty obvious that it has some implications. Again, the same element at the same position in the tree stays the same and preserves state, and it works like this for DOM elements and for React elements as well. So that is the thing. So the same element at the same position in the tree stays the same and preserves the state, and it works like this for the DOM elements also. Now in these examples we actually see that something has changed. However, it was not the element type that has changed, but simply the class name attribute in the div and the weight property in the search bar component. So these are the two things which have been changed. And so what React is gonna do is to simply mutate the DOM element attributes. So it will just mutate the DOM element attributes, and in the case of React elements it will pass in the new props, but that's it. So React tries to be as efficient as possible, and so the DOM elements themselves will stay the same only. They are not removed from the DOM, and even more importantly, the state will not be destroyed. Now sometimes we actually don't want this standard behavior, but instead a new component instance with a new state. So here the component, the search bar component will not be destroyed when the props are changed in the same position, means the component will not be destroyed. The same component will be used, but the props will be updated with the new props. And here the state and everything will most probably remain the same only. Remains the same only. So the whatever the state you are having is the updated state, it will be remaining like that only. So that is the thing. Sometimes what we want is we don't want this type of behavior. So we want to create a new component instance with a new state. So in this type of scenario, that's the place where the key prop comes into play, and we will learn about these more rules in the next video. So this is all about the diffing algorithm. So in the next video, we'll try to see about the real-time implementation of this diffing algorithm and the key prop also, where it will be useful. We'll try to see it. So that's it guys about the diffing thing. Hope you understood about this diffing thing. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will see about the practical implementation of this diffing algorithm, how it will work. For example, let's say that here we are having this is a brand new project, so don't think about this one. Just I will try to show you the example how this one is implemented. And let's go to the app.css, and I will open this app.css file also. Oh sorry, not app.js file, app.css. I think it is loading. Let's open it here only, app.css file. So here I have opened it. I am removing this all the code, and I will use star box sizing border box. This is the basic thing, and here I will remove this all the code. So just we will have a basic simple example, and I will have a div class name is equal to container, and for this container we will do dot container border width of around 90%, sorry 90%, and margin should be auto. Okay, oh, margin should be auto. Fine. And here in our app.js we need to write a code. So for example, let's say that we are having a tab data. So we are implementing a tab data. Let's say that I am having a tab data, which it will be having array of object. There is nothing but id, title, and content we will be having. Now in this one, I need to show this tab content. For this one, what I will do is I will create a new file, new component, that is tab.js. And here in this tab.js, export default function tab I will be having, and in this tab I will do return div tab1, and this is the content we will be having. Now this is a tab1 we will try to show. In our app.js, I will call this tab1 here. Okay, so here I will have something like div class name is equal to tabs, and in this one we will do tab. Okay, so this is our tab, and here if you try to see, this tab should be imported at the top. I think whether it is imported or not, I didn't remember. So tab is imported, and tab is not defined. Okay, here export default function tab, and I am writing this one. Yeah, fine. So now we are able to see this tab one. So let's say that we are having three right, and I will be having let's say for example I will be having 4 tabs, 1 2 3 4, and I will give this num also, that means tab number also. Num is equal to 1, and I will send these all the tab numbers into this one. So here I have sent these tab numbers. Now I need to capture this one here, num, and I will show it here in the props here, num. So tab 1, tab 2, tab 3, it should be dynamic here. Now let's say, oh sorry, these are all the 1 2 3, 1 2 3 4. So it should be dynamic here. I want to place it side by side, so here I can go to the tabs, and I will place it as display flex, and I will give something like justify content space between. Okay, so now it will be space between. Yes, fine, perfect. So now it is perfect. Now what I want to do is, so here this is the tab, right? So whenever I click on this particular tab, I need to show the tab content. So for this one we will create a new file, that is tab content.js. So tab content.js file, and here also let's go here and we will implement export default function tab content, and in this one I will return the div tab content. Okay, let's we'll show it like this. Now here in our app.js, and here I will be showing a tab content. So here I will be having something like tab content. Okay, so here I will, so now here at the bottom you will be able to see the tab content here. So this tab content should be dynamic, whatever the tab we are trying to proceed, so that tab content we need to show it. So here what I will try to do, I will try to send this one. So we need to have a state variable. So here I will have something like constant active tab, and here set active tab. I will use this set active tab is equal to use state of 1. So we will have it like this, use state of 1. So use state of 1. Now here we need to send, we need to check this, whatever the active tab is there, we need to show it here. Now here in this tab.js, what I will try to send is, so here we will be having set active tab, right? So here I will send it on click method. Okay, I will send this set active tab. So set active tab, we will write this set active tab here. In the same scenario, we will write complete on click is equal to set active tab, set active tab, set active tab. So we are writing it like this. Now this one prop, we need to take it here in our tab.js. So here in the comma, I am taking this one, and here whenever we click on this one, on click is equal to, okay, so we can call the method in such a way that on click, I will call this on click, and we need to pass the number. So that's it. So the set active tab will be updated automatically. Now here when an active tab is there, and here I will be writing the condition in such a way that active tab is there, then I need to show this tab content. Whenever this active tab is there, I need to show this tab content, or otherwise I need to show something like div not found. I will show something like this, div not found. So here I will write not found. So that's it. So whenever we have an active tab, so when I click on this tab 1, tab 2, tab 3, so we will be showing this tab content, and we will be showing is not found. So if I click on this one, so we will be showing this not found. So right now it's not working, we will see it. So now we have did these all the changes. Now if I try to click on this inspect element, if you go to the components here, oh, I think some okay, tab is not defined. Why this tab is not defined? Still these are old errors, I think. Tab is not defined. Let's refresh this page again, and if you see whether we are able to get it errors or not. Yeah, fine, it's working fine. Let's go to the components. Here in these components we are able to see all the tabs, and this is the tab content. Now this tab content we need to pass the data. So here if you try to see in our app, we are having a new entry state 1, right? If I click on this one, the state is getting updated, fine, right? So here the state 2, 3 is also getting updated, and state 4 is also getting updated. So now here you can write in such a way that if the active tab is less than or equal to 3, then only we need to show the tab content, or otherwise we need to show the not found. Now if you try to click on this one, so fine, it is working fine, and here also it is working fine. And if I click on this tab found 4, we are able to see the not found. So this should not, this is the thing we need to have. So now the tab content, we need to send a content. Okay, fine, we will send the data. Okay, so here in this data, what I will try to send, I will try to send the tab data of active tab minus 1. Why? Because it will start with 1, but the array starts with 0. So I will be sending active tab minus 1. So the data we have sent it. Now this tab in the data we need to highlight in the tab content. So here we got the data. Okay, we captured the data, and here in this one I will show the first one is the h3. Okay, h3 is nothing but data dot title, and the another one is the paragraph element, which shows that data dot content. So that is the content, and here I will close this div. Oh sorry, this is the paragraph element, right? So paragraph element. Now if I click on this tab 1, we are able to see this data. Sample 2, we are able to see this data. Tab 3 also we are able to see this data. So fine, so far everything is working fine. Now let's say that here I am having one anchor link. Okay, so here in this anchor link I am having href is equal to hash. So I will show this hide details. Okay, so if I click on this one button, it needs to hide the details. Now here I will use the state, so constant show content and set show content is equal to, so I will write it like this, set show content is equal to use state of what I can say here, use state of first time it will be true, so we will be showing the content, let's say show. And here when I click on this one on click, okay, and here I will call set content. So here it should be something like set show content, what I can say, of not of show content. So we will be having it like this. So I am making it as a toggling thing. Now if I click on this hide details, see here if you try to click on this hide details, hey, what is happening here, on click and all those things. So href, so we are writing the code, fine. Okay, so I need to show this all the details, right? So I need, oh sorry, these are all the things opening. Let's try it. Yeah, here I need to add a condition. So here if show content is there, if show content is there, then only we need to show this content. So here I will copy this entire thing and I will paste it here. That's it. Now if I refresh this page and if I click on this hide details, see we are not showing this one. So this hide details also it should be toggle. So that one is nothing but what I can say is, so if show content is there, then I will show the option is something like hide details. Okay, if the content is not there means then I will show, sorry, show details. That's it. Now if you try to see the output, so here if I click here like this, it is happening. Now you need to understand the concept, which what I am trying to tell is, so if I click on this tab 1, okay, we are able to see this hide details. Now I am hiding the content of this tab 1. Now when I move to the tab 2, what will happen? So the content should be visible and all those things, right? Why? Because in the tab 1 the state is hidden, but in the tab 2 it should not be there. Now if I click on this tab 2, so the title has been updated, but the content we are not able to see. So that means the state is getting retained. So the state is remaining in the tab content. Why? Because here you need to understand the diffing algorithm. So why it will happen is that the React element is in the same position and the element is also not changing. Only the thing what it is changing is the only thing that is nothing but the data, that is nothing but the props is changing. So in the diffing algorithm we have learned when the props is changing or anything is changing means, so it will not remove that element or it will not destroy that React element. So the diffing, the reconciliation, and it will maintain it like this only, and the state also will be there, it will be retained like that, it will not be destroyed. For example, whereas in the tab 4, now entirely tab content is removed. Now when I click on this tab 3, so now you will be able to see the entire data. If I click on this hide details, now the state will be retained in all the places. Now if I click on the tab 4, remember that we are hiding the content, but if I click on the tab 4, so not found is there. When I go to the tab 2, again the state is not recovered, so the state will be by default that is true. So this is what the diffing algorithm will try to do. So now it will try to remain the state in all the tabs, even though the tab content is changing, even though the component is changing, the data is changing, but the state between the components is retaining like this only. So this is how the React actually the algorithm works. So now in order to maintain like this, for example in tab 1 you have made this one to hide the details, but in the tab 2 this should not happen. So the state should not be like this. So it should show the details. So now if I go in the tab 1, the state should be reset. So in order to maintain this, in order to do this one, what we need to do is we need to maintain the key. So that key should be also unique thing. So here the ID is there, right? So here you can write a key is equal to, here I can write the tab data of active -1 dot ID. I can keep the dot ID. Now the key is unique. So now the way using this key, the diffing algorithm will try to create the instance for the component. So it will create the instance for every component. For example, in the tab 1 I have hidden the details. Now in the tab 2, if you try to see, the content will be visible. Why? Because the state will not be retained. So the state will be reset everything. So because of the key. Now if I click on this tab 2, see the data, it is there. This is all happening through the key concept. So this key is the main thing responsible. Now whenever you try to click, now here also I am trying to hide the details. So now if you go to the tab 3, again the state will be reset, the component instance will be recreated again. So this is how the diffing algorithm or the reconciliation works in the React.js. So whenever you don't want to retain the state for a component means, then you need to use the key property. So this is the most important thing. So hope you understood about the zipping algorithm thing. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will learn about the pure components. So this is also one of the important concepts which we need to learn in the React. Let's try to learn about these pure components. What is these pure components? In order for the rendering process to work, our render logic needs to follow some simple rules. So let's look at these rules in this video. First of all, what actually is render logic? So you may be having doubt, what is this render logic? Let's take a look at the two types of logic that we can write in React components. So that is render logic, and another one is an event handler functions. So these are the two types which we can write the logic in the component. Render logic is basically all the code that lives at the top level of your component functions and that participates in describing how the view of a certain component instances should look like. So render logic means nothing but we will be writing the JSX syntax and all those things, right? View. So that is nothing but a render logic. And here if you try to see the example here, so what is this, in the code there is a lot of render logic. So you will be able to see the state data, and also here the create list also you will be having this written, and it is writing the JSX code, and at the bottom the complete JSX code it is getting written. So these describe how the component will be displayed on the screen. So this logic is called the render logic. And now the blue color box which we are having here, the blue color box, right? This is called as an event handler function. Why? Because the handle new answer, the method will not be called instantaneously. When we click on the, when we change the input data, then only the function will be called. So that means this is an event handler function. Coming to the event handler functions, they are basically pieces of code that are executed as a consequence of the event that the handler is listening to. Code that actually does things: update state, perform an HTTP request, reading an input field, navigate to another page, etc. So these are the things that event handler functions normally does the things. This concept is all important because React requires the components are pure. So this component is this concept what I am trying to tell is important. Why? Because React requires the components to be pure when it comes to the render logic in order for everything to work as expected. So the components which you are trying to do, the render logic which you are trying to implement, so these are render logic. What it will try to do is the React, it will always try to think that it should be a pure function. What does this pure actually mean? To answer that, let's have a quick refresher on functional programming principles which are quite important in React in general. Let's start with the side effects. So a side effect happens whenever a function depends on any data that is outside the function scope, or even more importantly, whenever a function modifies the data outside its scope. So that is called as a side effect. Whenever a function modifies the data or variable outside the scope means, then it is called as a side effect. So let's try to see some examples here. So here if you try to see, here the function is mutating an outside object. So the constant areas is equal to an empty object which is present outside the variable, outside the function. And if you try to see the function circle area, in that one we are trying to change the side effect, so outside variable mutation. So we are trying to modify the outside variable. So this one is called as a side effect. This function is called as a side effect. Other examples of side effect are HTTP requests, writing to the DOM and more. The other important functional concept is pure functions, which are basically the functions without side effects. I will try to show you another example. These are the functions that does not change any variables outside its scope. When we give a pure function the same input, it will always return the same output. So this is also one important thing you need to understand. Whenever we send the input, whatever the input you send, whatever the same input you are saying, it will always return the same output only depending on the input. For example, let's say that here if you try to see, this is clearly a pure function. Here we are having a circle area. So if we pass the radius, at any instance, whenever you pass the input as 20, it will always return the same output only. So this is one thing which you need to remember. The same output, as long as you are trying to send, the same output we will be expecting. This is a pure function. We can predict this output. So these are the functions that does not change any variables outside its scope. When we give a pure function the same input, it always returns the same output. This function is completely predictable. So this function here is completely unpredictable because it returns a string that contains a date. So here we are having a simple example which is not a pure function. So in the same scenario we are having areas which is an object, and here we are having the same function circle area. We are passing the radius to that one, but this time we are having a date function which will take the current date, and we are calculating the area, and we are returning the date with an area. Here the spelling mistake for the variable, it should be date not data. So the date and the area we are sending the combination. So now this function is a completely unpredictable. Okay, why? Because every time when you execute this function, always the current date will be changing. So that means, so it will be changing with the seconds, right? So the output will be changing all the times whenever you send, if you send the same input also. The other function is completely unpredictable because it returns a string that contains a date, and date changes every second, and therefore this is an impure function, not a pure function. In order to make useful and bug-free applications, we need to know when and how to create a side effects. In React, there is one big rule which is that components must be pure functions when it comes to render logic. So whenever you are trying to implement the render logic, the component should be always a pure functions. So it should not do any side effects. This means that if we give a certain component instance the same props, so the same input, then the component should always return the exact same output in the form of the JSX. So now when you try to implement the, what I can say is, when you try to send the same props as an input, so always the JSX output should be the same. This means that render logic is not allowed to produce any side effect. So in other words, the logic that runs at the top level and is responsible for rendering the component should have no interaction with the outside world. So here what I am trying to tell, that render logic is not allowed to produce any side effect. In other words, the logic that runs at the top level and is responsible for rendering the component should have no interaction with the outside world. This means that render logic is not allowed to perform network requests, to create timers, or to directly work with the DOM API. So this render logic should not work with all the things. For example, listening to events using as event listener. So listening to events using as event listener. Now according to what we learned previously, render logic also not mutate objects or variables that are outside the scope of the component function. So and this is actually the reason why we cannot mutate the props. So this is the main thing why we will not mutate the props. Why? Because these props data is coming from the outside function, which is the rule of the React. It's because doing so would be a side effect, and side effects are not allowed. Finally, we really cannot update state or refs in the render logic. So in the render logic, we should not update the state or refs in the render logic. And updating state in render logic would actually create an infinite loop. So whenever you update the state, immediately the render logic will be executed. So this will be an infinite loop, and which is why we can never do that. State updates are technically not side effects, but it's still important for them to be on this list. Now there are other side effects that are technically not allowed as well, but we create all the time, like using console.log or creating random numbers. So these are clearly interactions with the outside world, but they don't seem to do any harm. And so we can safely keep doing them. So writing side effects are only forbidden inside the render logic. This means that we have other options. For running the side effects. So now in the render logic, if you don't perform the side effects, that means mutating or changing the outside scope variables means, then what we can do? So we have other options to doing this type of side effects. Second, if you need to create a side effect as soon as the component, So we saw earlier that event handler functions are not render logic, and therefore side effects are allowed and actually encouraged to be used inside these functions. So event handler functions are doesn't come under the render logic, so we can implement the side effects inside that one. Second, if we need to create a side effect as soon as the component function is first executed, so we can register the side effect using a special hook called use effect. So for example, let's say that when the component is first time loaded, it's first time executed, and you want to perform a side effect in that one. So you cannot implement that one in the render logic. So for those type of implementations like HTTP requests or API calls or anything, so you can register that side effect using a special hook called use effect. So this is the use effect which we will try to learn in the upcoming videos. So this is all about the pure components. So which component should be pure and which component should be impure, where we need to write the side effects code and where we need to write the pure code. So this is all the explanation about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi friends, this is Leela. Welcome to my channel Leela Web Dev. In this video, I will try to show you one concept in the React 18, which is exclusively in the React 18. So that is state update batching. I will try to explain you about that one. If you try to see here, this is our simple app. So I will try to remove this one all. So I will increase the font size also so that it will be very much clearly observable. So that you can able to see clearly. Yeah, here. And in our app.js, I will remove this logo also. And here just I have given a output of hi Leela, right? So let's try to see whether we can able to see it or not. So the output we are able to see it. Now what I want to do is, here in this one, I will create a simple, what I can say is, inside this one, I will create a simple heading. So that is nothing but what I can say is, so counter, or otherwise, okay. So I will create a header. So counter heading, okay. I will create it like this. Now in this one bottom, I will have a simple counter. So in the div, I will show some counter. Okay, we will have this counter. So that is nothing but counter, and I can have something like set counter, and by default I will keep it as a 0. So we are showing the counter. Now another thing what I want to do is, so let's see the output, whether we can able to see the output or not. So here I am able to see the counter as 0. Now I will add 2 buttons for this one. So here I will be having something like 2 buttons, button, so single increment, and another one is triple increment. I will do like this. So and also I will have another button that is nothing but reset, button reset. Okay, so these are the 2 things which I want to tell you, which I want to show. So now here if I try to show, so this is the reset we are having it, right? So now let's say that we are having a heading also, constant counter heading, comma set counter heading, okay, is equal to use state of, I will use something like counter heading. I am using something like this. Let's use this counter heading here inside this one. Okay, so that's it. Now these are the things. Now if I try to show you here in this one, so if I increment this counter, if I click on this button, so it should increment. So for this one what I want to do is, so I am writing an on click for this one, and here I will write handle inc. So this is the method which I am trying to do it, and here we will be having a function handle inc, and in this one what I can do is set counter, okay, and I will use counter plus 1, that's it, right? So now if I try to increment this one, plus, so it is incrementing. Now this is the triple increment. So when I click on this one, so this should be incremented by 3 times. So for this one what I can do is, so here I can do on click is equal to handle triple inc, okay, and for this one function handle triple inc. So I will do the same thing here. I will copy it this one, and here I will try to do 3 times. So this is how I will be doing. Now if you try to implement this one, on click, spelling mistake it seems, on click, okay. Now here if I try to implement the same thing, here if I click on this one, it is incrementing. Now it should be incremented to 6. If I click here, it is incrementing only to 4. So why is this happening? So here when it is incremented, and also you'll try to see whenever a state is getting updated, whether the component is re-rendering or not, you'll try to see it. So here I will do a console.log, okay, rendering. So here whether it is re-rendering or not, we'll see. So if I try to see here, the first time it is rendering, the gray color which is having, so you can leave that one, so it is coming from the development tools. So here the thick black color is there, right? So this is the actual rendering. If I refresh this page, first time the component is getting rendered. So fine, it's fine. Now if I click on this plus, so again a rendering is happening. Why? Because a state is getting updated. So that is the counter is incrementing to +1. So that is the reason it is getting updated. Fine. Now if I click on this +3, so the state is getting updated only one time only. And here we are able to see instead of updating 3 times, it is updating only one time. So for this one, what we need to do is, so here the set counter, first when you are clicking on this button, so when it is getting executed, first the set counter will be executed. So it will take the counter, the first value will be the 0, 0 plus 1, 1 it will be. So you know that these all the updating and all those things is synchronous. So by the time it goes to the second, the counter will be still 0, 0 plus 1 it will be 1. And here also 0 plus 1 it will be 1. So when the state is actually get updated is when it is rendered. So when the component is re-rendered or during the re-rendering, when the virtual DOM is getting updated to the fiber tree, then only the state is getting updated. So here immediately if you try to see, the state will not be updated. So in order to overcome this type of issue, what we need to do is we need to use a callback function. So here we need to use a callback function like this. So it is a good to use the callback function so that you will not encounter this type of issues. Now if you try to see here, so if you see the output for this one, so I have incremented to 0 plus 1 plus 2. So here it will be updating. Now if I click on this triple plus, see it has updated to 5. And also observe the one main thing is the component is rendered only once instead of rendering thrice. Why? Because so here the state is updated 3 times, right? So for the first state update, the component should be re-rendered, and the second state is getting updated, again it should be re-rendered, and the third time also this got so total 3 times it should be re-rendered, the component. So what we have learned in our previous videos and all those things, so whenever there is an update in the state or the props or anything, so the component instance will be recreated. So but here this is not happening. So because of this one, so what is this one is called as an batching update. So the React updates the state in batching. Now for example, let's say that here you are having a reset button. Okay. So here I will use on click is equal to reset. I am using a reset method, and here let's try to implement this one function reset. So in this one what I will do is set counter, I will make it as a 0, and here also I will do set counter of empty, not empty, set counter heading. So here I will do set counter heading of empty, or otherwise Leela, I will change it to heading. Now if you try to see here, counter heading we are using it, right? So when I try to update here, so first time, so it is there, so counter heading and 0 it is there. Now single rendering is happened. Now when I click on this triple plus, so single rendering is happening. And now if I click on this reset, so let's try to see. So single render is happened, and Leela and 0 both the things has been updated. Now if I click on this reset, so again rendering is happened because of the state update, this one 0 thing. And now here if you try to see that, now here if I click on this reset again, so already the state is the same, right? So because of that reason, already the state is same, because of that reason the rendering is not happening. So this is what it will happen. So when the state is already the fiber tree, that virtual DOM tree is one and the same only, then also the rendering will not be happened. So here if I click here, again rendering will be happened. So this is how the state update batching will be going on. So when you are updating the state which is its default value, then also it will not update, the rendering will not happen. And also when you are trying to do the multiple states and all those things, only single time rendering will be happen. So this is one thing you need to understand. So this is how the state update batching will be occurred. So this is in the prior to React 18 like React 17. So this state update batching will not be there for this one. So for the set timeout and promises also, React 18 supports the render batching. For example, let's say that, so you are having something like what I want today is undo or anything, undo in 2 seconds or anything. Okay, and here undo, I will use an undo method. So this method, let's try to call this method function undo, and in this one what I will do is, or otherwise okay, set timeout, I am using a set timeout, and in this set timeout what I will do, I will call this reset function, and this should be executed after 2000 seconds. That means after 2 seconds. Now if you click on this undo, so this is an what I can say is undo is not defined. Okay, so it's a function, right? Oh, function undo I have implemented. Undo is there, everything is there. No, hopefully it should work, I think. Yeah. So now if you try to see, the first time it is re-rendered. Now if I try to do increment and if I do undo here, so nothing is happening. After 2 seconds a single render will be happened. But here the state is updating 2 times. So here the state is, the 2 states are getting updated. But here only one rendering is happening. Whereas in the React 17, this set timeout promises, so that batching state update will not be happen. So this is what I want to explain you in the React.js and the React 18, that update state batching, but the state, whenever the state update is happening, it will be updated in the batch. That is what, and also the single rendering will be happen. So hope you understood about this state updating. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.